One key aspect that the simulator can demonstrate very well is how an evolutionary process can act on one species to create many species that fit the environment that it has evolved in very well. So let me demonstrate by example. I have here the first pattern from the preset patterns. I will stick the start point in the middle and off I go with a simulation. So you can see, as always, here a species has been inserted, has been created, and because it's on a positive cell it will increase its population, and with every increase in population there's a chance of genetic mutation, and that's happened in that last cycle. So we can see here a few of the individuals from that species have mutated, and so we have one species that's moving into this neutral territory and one species that's moving into this positive territory. And if we fast forward this, I will just keep clicking to move the process along, and we see what's happening is that process is occurring over and over again. So new species are being created, and as they move into positive territory they have a greater chance of surviving and their population tends to grow. If they move into negative territory they can still survive but are less likely to survive, and so their numbers when they move into negative areas are a lot smaller, and they're a lot more likely to perish and to not compete against other species that utilize more positive space. So we can continue along here and we see the process develop until the entire available environment is pretty much consumed, and then we just have the interactions between the species. But we can start this process over and over again. Let me pick a random selection, stick it in the middle, start point in the middle again, and once again, no matter how complex the environment is, if the species can likely mutate into that new area, then it will do so, and the species as a network will evolve into many species that fit the environment, some would say almost perfectly.